Um, David has been involved in the small boat business, I guess, I don't know, when I come to Mystic, I was at Mystic 78, I think I met you, must have been around 80 or something like this. You was a graduate student in those days, I think. And he's been involved in small boats ever since. He does have some additional qualifications. Interesting qualifications is that he has recently retired as a engineer as one of GM's engineers. And Catherine's around here too someplace, who also recently retired. So now they have a little bit more time to put into the boat business. They do live in Michigan, but that's okay. That means they can get to both coasts with equal ease by more or less. Anyway, one of the things that I asked Dave and I were talking about was getting involved in photogrammetry and other kind of technical ways of getting information off of from boats. But what I was interested in actually was what we've learned over the years in boats that we have measured in the small boat trade, and could we get useful information from all those stacks of plans that are out there and so forth. So David figured out how to do it, and so he's going to focus on, Walt Simmons isn't here, so I guess I can say Peapod, but you know, Walt said that out in Matinicus they always call them double enders, and I think he's probably right. So we're going to focus on the smallest workboat. So David, why don't you come take it away?
Okay. Yeah, I realized it's always a little bit risky being from Michigan, and I grew up in Maryland, and coming to Maine to tell you about peapods. So somebody asked me, you know, what's the definition of a peapod? And that's a good question, and I'm not going to give a definitive answer, but here's what I think, what I found. Peapods have to be double-ended, round bottom, and they're found along the Maine coast. It's been said, also referred to as double-ender. You know the size, et cetera, usually 13, 16 feet. Uses, inshore lobstering, as a dinghy, transportation to and from lobster boats, et cetera, travel, communications, lighthouse service and Coast Guard used them, recreation. Origins are obscure. And one of the interesting things about the Peapods double enders is, best as anybody can figure, they're not an ancient boat type, probably originated in the latter half of the 19th century. Go kill that. So that's a picture I got yesterday down at the apprentice shop in Rockland. I think that's the Matinicus boat, that so-called Matinicus boat that John Gardner and Dave Dillion have done. This is one under construction at the apprentice shop. We're doing it for one of the lighthouses, and it's thought to be a boat that was originally done for the Coast Guard, the design. So, some statements about peapods. Authors of a couple of these statements are here in the room. Other ones are attributed to late, well-respected folks. Found favor with Lathpot fishermen because they could manage a heavier load than a dory. Boats smaller than 15 feet just wouldn't be a decent pod. 15 feet's the average length, and they're exactly the same on both ends. Need to support 200 pounds on the gunwale, and they're as different as the men who used them and built them. So, Ben alluded to, this is focusing on the hull shape differences and how they affect performance. Basically took lines and offsets and converted them to 3D computer models, and then I've looked at analyzed those, and we'll get into the differences for the ability to carry load, stability, and resistance or drag when you're rowing one. So that's just a graphic of how it went about the study. Boats evaluated. I'm not going to talk about each one of these now. We're going to, a little while later, go through a little bit more about each boat, but divided them to what I call the historic pods, ones that kind of were built along the coast of Maine, et cetera. Some later ones really, you could say ones that somebody went out and designed using drawing them out and so forth, although John Gardner did at least one of those with a half model, and then got a couple boats for comparisons, those dories and a flatty skiff. So that's the 15 peapod models that were used. I don't expect you to see the differences that clearly, but I think you can see that there are some differences in the shapes. So let's start looking at size, and I got some plots here of length overall on the left and beam overall on the right. And there's a pretty good range in size. The North Haven Allen boat is 13 feet or so, and John Gardner's 16-foot rowing one's really closer to 16 and a half feet, and pretty much everywhere in between. I did not include the little one that Bob Baker drew up and Maine Maritime has plans for, which is down closer to 12. I also didn't include a couple larger boats, which are up in the vicinity of 18 feet or so, and are really more kind of big sailing and power boats. And you can see the beam runs from a little bit under 4 feet up to 4 feet 8 inches or so. Now looking at this, it's not real clear, you know, what's a big boat, what's a small boat. So another way to look at it is, well, actually I should say, get to that in a minute. Proportions, beam to length ratio ranges from a little bit over 3 to a little bit less than 4. So in other words, the beam's from a quarter to a third of the length. So size. Another way to look at the size is to take the pod, cover it over from rail to rail, and find out how much volume that encloses. And there's a pretty good size ratio. Smallest one's at North Haven Allen at about 42 cubic feet. The biggest is the Coast Guard designed one that they built down in Curtis Bay in Maryland and used in Maine and other places, which is a little bit over 80 feet. So that's a 2-to-1 spread in volume. And I think those are the two boats illustrated on the left. You can see there's a pretty good size difference between them. Ability to carry loads. I'm not getting into the coast, you know, the recreational boat safety standards, et cetera, but one thing you do worry about in carrying a load is how much freeboard do you have. You know, a wave's going to wash over the side, is the boat going to sink, et cetera. So we're going to go through and have a look at how each of these individual boats compares on the slides. I'm going to show you overall ones first. But you can see there's a pretty good range of freeboard. At the bottom, it ranges from 300 pounds displacement to 1,500 pounds. That's the total weight of the boat and whatever the boat's carrying. 300 pounds is probably, some of the small boats with a single person in them would be there. 1,500 pounds, you're pretty well loaded up. And there's a pretty good range of how much freeboard you have, about 8-inch difference or so between the smallest and the largest at any given load. Stability. Any naval architects here? Okay, I'm going to look at stability in general a little bit different than naval architects do. They're using the same basic methodology. So this is, again, that displacement at the bottom from 300 to 900 pounds. And the vertical is the metacenter height above the center of gravity multiplied times the displacement. I'm not going to try to explain what it is. More means the boat, larger value means the boat's going to be more stable when it's upright and you move to side a little bit. And there's, again, a pretty good spread of what the pods are. Some are going to be pretty stable, and others are, you know, 2 to 3 times spread in that. And the other interesting thing is those curves are not all parallel. So as you start to add weight to some of the pods, they're going to feel a lot stiffer than some of the others. Writing arm, I put this in case there are any naval architects. I'm going to give you a different way of looking at it. This is stability in terms of how much weight can you put on the rail. You got the boat loaded, now you're going to take some of the weight from the center of the boat and move it out to the rail. What happens with that as freeboard over there, vertical, axis. So if you don't have any weight on the rail, you're sitting nice and vertically, and you've got so much freeboard. Now you start moving weight out to the rail. You as a person rowing moves, or you're a lobsterman and you're hauling a trap and you move over. And what happens to freeboard? And you get down to zero. And generally, if you go beyond zero, bad things happen. So there's a pretty good range there. And, you know, we quoted somebody as saying you got to be able to put 200 pounds on the rail. This, by the way, is loaded at 600 pounds. If you put 900 pounds in, you can put some more weight on the rail. But if you look at 600 pounds, which is, you know, reasonable load on some of those pods, you're looking at 120, 160, 180 pounds on the rail. There's not too many of them that you can put 200 pounds directly on the rail. Resistance, how hard do you have to row? Should say, I got individual points here, and then I just connected the points with straight lines. Otherwise, Microsoft Excel put some funny shapes in the curves. But you can see that the resistance starts out, resistance in pounds versus the speed in knots, and starts to increase as you go up in speed. And you get up and there's a kink in the curve. You've probably heard of haul speed. That's basically quote unquote haul speed. Doesn't mean you can't go faster. Put a 15 horse on one of these boats and they will definitely go faster than 3 or 4 knots. That's as long as they stay upright. But your resistance starts going up. If you're into boats and know about speed to length ratio, that kink's happening at a speed to length ratio of about 1.2. The biggest and there's 2 groups there, which is kind of nice. They sort themselves into 2 groups. The biggest, by far, impact on exactly where they fall vertically up till you get to haul speed is dependent on the wetted area, skin friction. It's not the details of the hull shape. The point where they turn up that haul speed is directly related to the waterline length. So let's look at the historic pods in a little bit more detail, and I've got 2 slides for each one. This is the smallest one. Was used on North Haven by Frederick Allen a long time ago as a supply boat, and there was a haul over between Southern and Bartlett harbors, so he wanted a nice small light boat. You can see it's the shortest, it's got the smallest beam, and it's got the smallest volume. And got the lines at the top. If you're not used to looking at boat plans, what those curves are is basically you take the shape of the boat, the hull, and down here in the lower right is a waterline. So if you make slices, like you're making a loaf of bread, but you're slicing horizontally at 3-inch increments, you get a set of shapes, curves that look like that. Above that, I'll call it buttocks, and that's if you go vertical slices parallel to the center of the boat, in this case at about 6-inch increments. And then in the upper left is looking at it from either end. On the right, it's from the bow, and on the left, it's from the stern. And those are sections, again, where you go and you cut the boat, section it, vertical sections, but perpendicular to the center line on about 1 foot basis. So you can get an idea. That's a fairly small boat, pretty flat sheer, etc. Now, I don't know if you can read them. The plot on the far left is that freeboard versus displacement. And I hope you can tell there's one curve that's been highlighted in black. That's the one for the particular pod we're talking about. Same for the other ones, that initial stability curve, the 600-pound displacement, stability at 600-pound displacement, freeboard versus the weight on the rail, and then the resistance force. So this Allen pod, from a freeboard versus displacement load carrying, it's not the lowest, but it's getting pretty close down to the lowest. Initial stability, it starts out not quite the lowest, but you start loading it up, and it's going to be the least stable boat when you get in, and just how's it feeling as you're initially sitting in the middle. The overall stability, again, not the lowest, but one of the lower ones. It's a good boat for rowing, though, in terms of speed. It's about the lowest up until you hit that haul speed, and because it's the shortest, it's got the slowest, quote, haul speed. One of the boats which is probably as representative, or is taken as representative of the Penobscot Bay region boats, is this Alton Whitmore boat, built on North Haven around 1929, or said to be built North Haven. There was a photo that was shown earlier of, no, it was yesterday, last night we saw the movie, of a pod under construction in a boat shop back, I think, about 1910, and that was also Alton Whitmore's thing. So this pod's down at Mystic Seaport. Plans are in John Gardner's classic small craft you can build. Its length is about average, its beam's about average, and its volume's roughly about average for the boats we're considering here. So it's, you know, kind of an average size pod in that respect. The shear's fairly flat. It's got fairly flat in the middle section floor, and then sort of turns up, low dead rise, and turns up fairly sharply. Freeboard versus displacement. For the length pod it is, this one's pretty good at carrying a load. Initial stability right down the middle. Overall, you know, stability in terms of weight on the rail, that's down the middle. Pretty good average pod. Resistance force, pretty low. It's not a lot of wetted area for the ability to carry the load. So it looks to be that's a nice pod. Now, this question of 200 pounds, I'll come back to this one. You know, this pod, I believe, was used for lobstering. And if you got 600 pounds overall in that pod, I think it's estimated the weight, and I don't quite remember what it is. But anyway, you can only put about 180 pounds on the rail. It doesn't meet the 200 pound on the rail test. Another one, boat which used to be attributed to Whitmore, and I think a little bit more research said it was in fact built by Mark Wadsworth, who was a lobsterman in Rockport, who learned building from Alton Whitmore, is this one. And I don't have an easy way to back up, but I think hopefully you can recognize that it's got a little bit different shape than that Alton Whitmore pod. So at one point it was, oh yeah, Wadsworth was just using the same set of molds. No, he wasn't. He may have used the same pieces of wood if he cut them away drastically, but there's some significant difference in the shape. Another feature on this one and the Whitmore one is the keel is a plank that gets up to be about 6 inches wide in the middle. You can see that running down, you know, right in there. And there's several others that have that kind of feature as opposed to just a almost square type of timber running down the middle. And the other interesting thing which only shows up on this is up here at either end you can see the end of the stem, no, the drawing, and then the rabbit running down. And see that rabbit line's got kind of a sharp corner? And all the others curve up nicely. Not quite sure why he did it that way when everybody else was putting a nice smooth curve on, but he did. And I've been looking around to see another round bottom boat from the coast of Maine built that way. I haven't run across one, I'm sure there are. So this boat's a little bit longer, a little bit more beam than the Whitmore boat, a little bit bigger volume. It's getting up there in load carrying. You're going to see that the two boats that have significantly more load carrying ability than this one are in fact considerably bigger pods. initial stability is not nearly as good as like that Whitmore one we just looked at. And that's because the bottom is narrower. Before the turn of the bilge, it's considerably narrower and the ends are fairly well pinched in. But it recovers fairly quickly when you start heeling it over. So the initial stability is pretty, or the overall stability is about average. It can carry about 160 pounds on the rail with 600 pounds displacement overall. And again, it's like a lot of these smaller ones, pretty good for rowing up until you get to hull speed. Matinicus one, Lin Young, and this boat's here at the museum, isn't it, Ben?
Yeah, it's in the Old Town Hall.
Yeah. And you walk in and you look at this boat, at least my reaction was, that thing is not going to be very stable because it's got pretty high dead rise, narrow around until you get to the turn of the bilge and turns up. It's pretty decent sized boat in terms of length and beam, but its volume is less. And it's got the nice rounded stern and so forth. Another one, if you look carefully at the two halves of the section drawing, you might be able to notice that they're not quite symmetrical. So that boat was not built exactly symmetric. Now, whether that was intentional or whether that's the way it wound up, I don't know, but I'm guessing a little probably intentional. Freeboard versus displacement. You don't want to real heavily load this one down unless you expect to be in fairly calm water. And also at some point that gets to be an issue of rowing unless you've got, I can't remember if this one had the oar locks raised way up. Yeah. Initial stability, about, lower third. Final stability, overall stability, second lowest. And it's good for maybe 140 pounds on the rail. And resistance, how hard you're going to have to row it. It's about the top one of that lower group. So you don't want to get in a rowing race with somebody else, although it's not a huge difference. For the same force rowing, you're looking at a couple tenths of a knot speed difference. Howard Chappell put this one in his American Small Sailing Craft. It's figure 82, yeah. Called it a lobster fisherman's peapod, and then he said it's also a model claimed to be used by lighthouse keepers. And I think he got this one from a half model. It's not all that long. It's 15 feet, 3 inches or so. It's wide beam. It's about the widest pod. It's the second highest volume. This is a big pod. Again, not quite a symmetric boat. It's the second highest one in terms of freeboard versus displacement. The top of initial stability, almost the top of the overall stability. So you can put a good sized load in that boat and go out and feel pretty stable. Resistance, you jump up to that higher group. So this one you're going to really either have to row hard or you're going to go slower than in some of those other ones we were looking at. This is an interesting one. Edson Schock, and I think it may have been the younger, drew the plans up 40, 50 years ago for Mystic Seaport, estimating the weight of it as built at around 300 pounds. It's a fairly long boat, fair amount of beam, volumes getting up there a little bit, quite rounded. I think you can see the stem, stern, pretty well rounded. Again, not a symmetric boat. Freeboard versus displacement, about middle of the road, same for the stability. This is a good boat if you want a boat that can carry some load and also easy to row. It's long, so that hull speed's fairly high if you want to make her burst, and the wetted area is down, so it's pretty good that way. probably would make a decent boat with a sail on it. This one's Cape Split. I have to say, when I was looking at this boat, and I didn't bother to read the information that was on the plan. I think the information actually been put in the notes with the Peapod DVD. I looked at this thing and I said, I bet the reason this boat's been around is because somebody built it and turned out it was a disaster to use and it was hardly ever used in the water. Because it's more like a fat canoe than anything else. In fact, I think Mad River built some canoes about this shape, except not quite as wide, a few years ago. But it turns out it was used, somebody lobstered from it for 50 years. Claimed it was, could be rowed at 6 knots with 7-foot oars. I hope the owner had been on the U.S. Olympic team rowing. That it empty, he could put 2/3 of his 185 pounds on the rail, and with 270-pound pots inside, he could sit on the rail. So if you take 210 plus, the 270 pounds and 185 pounds, you get up around the 600 pounds. Again, its volume's pretty small, even though it's a long and beam's about moderate. This has the lowest freeboard versus displacement, about the lowest initial stability, lowest overall stability, and it's, of that lower group, it's the worst one for how hard you're going to have to row unless it's got the highest hull speed because it's long. But so I think this also brings into question that, were the boats that people were using the ones that were perfectly adapted to their situation. If I was out shopping for a pod to go lobstering in, I don't think this would be my first choice, but somebody liked it for 50 years.
It had a lot of chafing gear on the rails where it was used.
Yeah.
But it wasn't a great boat even to just walk past it.
Okay. This is another one that Chappelle put in American Small Sailing Craft. He said it was built around 1889 near Jonesport, used by the Lighthouse Service, and he thought maybe government naval architects or somebody had some influence on the shape. This one, if you look at the plan view, those water lines, you can see it's almost parallel-sided in the middle. Over here, Ben. What I'm getting at is right across there. Yeah, it's pretty well parallel-sided, and then the ends are pinched in. So it's one of the longer ones, one of the wider ones with a fair amount of beam. You also notice it's got a real wide, from when you're looking at its side, stem, stern post, and keel under it. Probably try to make it sail reasonably well. So older design, interesting one, not quite those earlier boats we were looking at before tend to be a little bit from further west. This is, supposed to be from out around Jonesport. Upper middle in terms of freeboard versus displacement, and despite being a kind of almost boxy boat, that initial stability, it's the worst one lightweight. Now, I'm not sure you could build this boat and put anybody in it at 300 pounds, but it's kind of darn bad, and then when it gets immersed, it gets better. I first did this, I said something's wrong with the data. I thought about it. I think what's happening is that deep keel is tending to push the boat up out of water, and at lightweight, it's almost trying to balance on that, and once you get it immersed, it's starting to stiffen up. So at 600 pounds, the stability's middle of the road. This is the boat you get your friend who you're trying to beat in the rowing race to row. Washington County, become somewhat of an iconic boat, as Matt talked about. Definitely not a symmetric boat. Pretty asymmetric. Actually starts to look a little bit like the so-called cod's head. Yeah, whatever it is. Yeah, cod's head, mackerel tail type of design. Fat in the bow, leans, softens out. You know, thinking that this is pretty old, Chappelle, when he, in American Small Sailing Craft, said he thought it was about 1886. When I look at this design, I almost think I could kind of cut off the aft quarter or third of it and fare in a nice transom type stern. So it almost looks like you took a boat with a transom and then said we're going to turn it into a double-ended. Don't know, that's just my speculation. Pretty good sized boat. Freeboard carries a fair amount, pretty stable. Overall, it ties with the previous one for highest resistance. Neat boat, though. I mean, from just appearance, I really like it. I'm not sure, though, it's the boat to go take for a sailing race, even though it's generally sailed. Some later ones. Coast Guard had Peapods. I've seen pictures of them up and down the Maine coast. I think they had them elsewhere. Went through a couple iterations. This was plans that were drawn up by the Coast Guard. Apprentice shop down in Rockland has a pretty poor copy, but could get the information off of it. It's a big peapod. This is the biggest one I looked at. Other than it's not the absolute longest, but overall it's a big pod. A quick aside, some of you may remember reading John Gardner, National Fisherman, about 40 years ago about the small craft, the threatened small craft regulations. And in fact, John took one of his peapods, which he owned at Alton Whitmore, the second one we saw. I think that's the one he took out in the river there at Mystic, and he weighted it down to prove that the Coast Guard at the time was proposing some stability standards and so forth, that this was completely ridiculous. And he wrote that, you know, the Coast Guard, he demonstrated by testing his peapod that the Coast Guard peapods would be unusable for how they use them with their proposed rules. They're not the same pod. I mean, that's like getting a little Econobox sedan and a half-ton pickup truck. And yes, they both have 4 wheels, etc. Not quite the same. So big pod. Also pretty heavy. I made a rough estimate at the weight and came up with 425 pounds, and I think that's pretty reasonable. It's by far the deepest, most depth to the pod, and a pretty flat shear. So it's up there, will carry the most load in terms of freeboard. Initial stability is not the highest, but the overall stability is the best. It's also going to be one of the slowest when you're rowing, unless you got 2 or 3 guys from the Coast Guard in there rowing hard. And it's also almost symmetric, not quite. They just changed kind of it's pretty close, just the end of it is. This is the Matinicus Island peapod that John Gardner drew up, and then Dave Dillion redrew, and there's been a whole bunch of them built. If you read what John Gardner wrote, he said somebody sent him a photograph, and he used his knowledge of pods to draw these lines based on what was in that photograph. And it seems to be a very nice peapod. It's a lot of ways close to the Whitmore and the Wadsworth ones. I don't know how close it actually is to the Matinicus Island one. It's pretty much different than the Lynn Young one. I didn't get, who was the other Young that Walt uses?
Merrill.
Yeah, I didn't wind up with the Merrill Young design, so I don't know how it compares to that, but it's not that, just looking at the dimensions, it's not that close. A little bit longer than average, pretty beamy, decent volume, pretty good load carrying, nice stable boat. Yeah, flat in there. And it's also got the, it's more wetted area So it winds up being a little bit slower to row than like the Whitmore and the Wadsworth ones. Gardner also drew up a 14-footer that was used for a recreational boat building class. Again, pretty much a kind of middle-of-the-road pod, nicely rounded on the stem and stern, intended to be symmetric. Not a huge amount of freeboard, pretty stable pod, and should row better than, should row decently. This is his rowing one, and it's 14 feet, a little bit smaller beam than the previous one, although it works out to be more volume overall because it's actually got a little bit more freeboard, I believe. Reasonably stable boat, etc. And then he designed back, he said in 1951, this one for rowing on the St. Croix River. It's the longest one we've got, relatively beamy, decent sized volume. It's got one of those plank keels also. Kind of middle of the road. It should be a good pod for rowing. This one and that, probably Deer Isle are probably the ones to build if you're going to peapod racing. And the last pod is Howard Chappell's boat building has one that Gardner quotes Chappell as saying it's a typical lobsterman's rowing pod, and boat building came out in '41, and Chappell had been at least having a boat built a couple years earlier down east. So I think it probably is fairly close to that. Pretty reminiscent of what Chappell called his lobsterman's pod, although not the same. I mean, there's significant differences. Upper middle size, freeboard's about the same, a little bit higher stability than others, resistance force 9. I think this could be I don't know if many of these have been built, but it looks to me like that could be a real nice pod. And the only difference in the symmetry is the shear is slightly lower at the stern than at the bow. But you get below that and they're identical. Real quick on comparison boats, those dories, which from what I've seen in photographs were used for inshore lobstering. Like there's that book of photos from around 1910 from the Tinnicus, Monhegan rather. And so this one, compared to the other pods, is kind of averaged a little bit bigger, 12 foot on the bottom, about 15.5 on the side. Freeboard's good. Stability's got a completely different characteristic, being a dory, and don't have good estimate of resistance. This is a bigger pod from American Small Sail, and I got the wrong length up there in the text. It's a little bit over 18 foot, big beam, big volume, can carry a fair amount, but again, that stability is, those two are different. And a flat bottom skiff. Those are used up and down the coast. This is just one I found in John Gardner's book and said, yeah, it's a reasonable sized one. A little bit of, average length, pretty wide, shallow. Different characteristic on stability again. The initial stability feels pretty good even if you're lightly loaded. The overall stability's got that crazy curve because you're changing how much the boat is immersed. And resistance, I don't have a good estimate on this. So are all pods exactly the same on both ends? No. Can a good peapod support 200 pounds of weight on the gunnels?
Not many. Yeah.
A few, not many.
You said a good people.
Good peapod, yep. Says this is, he says a good peapod will support 200-pound weight on the gunnel. Two different statements here about 15 feet's the average length, and anything smaller than 15 feet doesn't deserve to be called a pod, just about. There's a bunch of them, particularly down from Penobscot Bay area, that are less than 15 feet.
They were tenders.
Yeah, we did.
They were tenders versus
workers.
workboats that were laying on an inclined way at a Coast Guard station. And that,
Yeah, they're different uses, but, yeah. Let's see real quick. Manage heavier load than a dory, not really. They behave differently, but not that much different. As different as the men who used them and built them, well, I don't know too much about the men that built them and used them, but I think there is considerable variety. So that's what I have. Questions, anybody? Still trying to digest it, okay. Yes?
Are you going to be able to share your PowerPoint presentation, or are you willing to?
Yes.
Where can we get it?
I don't know, we'll work that one out. I should say I've got a huge amount more data. It took quite a while to get all those CAD models built and get the basic analysis running. You put it in Excel and generate infinite number of curves just about. John?
would you like a set of lines and a photograph of them in build with the interior layout for each one of those? Because I think I probably have them in my computer.
Yeah, and a lot of that information's also on the drawings I got also, but yes. Yeah, back?
I wonder, when we were looking at the freeboard, I wonder how much wind resistance has to do with that, and if you considered that at all.
No, I mean, that's clearly true that if the higher freeboard, the worse that's going to be. I call it load carrying. You know, if you're to competitive peapod racing, you probably want the lowest freeboard that you can for the distance. Or, you know, just if you're rowing on a windy day, you don't, that Coast Guard pod with the high freeboard would not be a nice boat for one person to row with any kind of wind blowing. Pete?
For another interesting project might be to take this data and compare it with a comparable size, say a 14-foot Amesbury-style dory, also a beach fishing boat.
Yeah, and I've thought about that. I've also would like to at some point get the that Bangor Pool Peapod, or so-called Peapod, in Rangeley Lakes boats, St. Lawrence River skiffs. I mean, this can keep me busy for quite a while. I've got a few other things to do also. Anybody else? Yeah.
In terms of load carrying capacity and rowability, what was the pick? The Chappelle?
Yeah, I think the Chappelle boat building one looks to me like that could be a nice kind of overall Peapod. In pure just ease of rowing, the probably DRI or Gardner's 16-foot rowing. Having said that, as I saw earlier, there's kind of two groups of those. And within a group, for the same amount of work rowing, you're only looking at a 1/10 of a knot or so difference. So if you're racing, that's significant. If you're just out recreational rowing, or rowing out the lobster boat, I don't think you're going to see the difference. It's that you get higher speeds up above that hull speed where the hull shape makes sense. Yeah, quick.
Asking specifically about the rowing resistance, how did you come up with those?
Okay, I should have said that's approximate numbers, but they're pretty decent. It's using a regression formula based on, that came from Delft in the Netherlands, have a towing tank. And that one's actually the formula they came up with after testing, I think, about 1,500 different configuration speeds and so forth of ocean racing boats, that if you squint your eyes enough, you can convince yourself they're sort of similar in shape. I don't have a lot of faith in the absolute numbers, but at the slow speed, it's dominated by the wetted resistance, which is pretty good. Anything else?
Back in the late 70s, the apprentice shop in Bath built a 15-foot Gardner Metenicus pod and the Washington County Peapod. And they held a series of races on the Kennebec River, switching crews. And the Washington County pod with the plank on edge keel sailed much better than the Metenicus one, but the Metenicus one was simply lighter and rode better.
Yeah, that's what I would expect exactly. And it's bigger ones with sail rigs, and I think Chappelle in American Small Sailing Craft says that you could just divide pods into two groups, the bigger ones that were intended for sail, to be sailed and rowed when you need it, and the smaller ones which were basically rowing craft, and that seems to be borne out with what I've seen. Okay, one last?
Yeah, in use, having been around these pods through the virtue of the apprentice shop, there was a man and a dog, a man and a buddy, and 2 men and a boy, and then 3 men. And some of these boats, you get 4 people in that thing, and it'd still be a decent boat, and other ones you'd be swimming.
Yeah.
Whereas some of them pods, boy, that's the first one I'd walk up to if I wanted to go out to Curtis Island or
and
Island,
you know,
short hop, skip, and a jump.
I think that initial stability, you could see how the initial stability varies, and some varies with them in the load. And I've also run overall stability, and
That's application. I mean,
yeah, there's
if you
a
had
big
all on
difference.
beach, which one would you walk up to depending on what kind of day it was?
Yeah, I mean, there's in a lot of ways there's much different scale, but between these is if you're into canoes, something like an old town wood canvas canoe versus a Jensen racing canoe.
There's a lot more difference between those.
Yeah. But there's significant difference. Okay, thank you.